Hey guys, this is how to answer this question. This requires to use method of sections, as you can see, not joints, because there's way too many joints. So what we're going to do is we're going to create a free body diagram of this first. We're not going to jump into these free body diagrams yet. Do this. Okay, boom. So from what we can see here, there is no horizontal loading. Right? There's nothing going horizontally, there's nothing going diagonally, there's literally nothing. So this automatically is equal to 0. Now to figure out dy or ay, we can calculate the moment at A. Okay? And therefore 12 kilometers, it's going down, it's going downwards. So if you see right, it's going clockwise. So it's going to be negative 12 times by 6 here. Add, because of this, think about it, that's anti-clockwise, it's going up like that way. So that's going to be dy dy times 9. Okay. How do I know this, by the way? You get these values 3, 3, 3. Okay. 72 negative plus dy times 9. dy equals to 8 kilonewtons. Boom. And define ay, same thing. I mean, it's pretty obvious. If it's 12 going down, there's 8 going up, that means this has to be 4. So ay equals to 4 kilonewtons. Now let's use the left body diagram. Alright, you can pick which one you want to do. The reason why I would pick the left one is because let's see. I think it's because it's easier. I trust. I forgot the reasoning, but just trust me. Alright, so that's the method of sections here. Okay, let's do this. Y, X. You can do either one, you'll get the same result. Okay. So there's point A is 1 vertical loading, which is just 4 kilonewtons. Alright, don't worry about it too much. Don't draw the horizontal, there's no need to. G, E. Now this is what you do the arrows, that's the method of sections, and do the little circle stuff to show that you know what you're talking about. C, E, G, B, and A. Alright, perfect. So this is the little trick that you need to use. You need to first know that to calculate everything, instead of using f of x or equilibrium equations f of y, that's not really going to help you, simply because you have way too many unknowns. I mean, you have 1, 2, 3, right? What you need to do, okay, well, you could use the f of y equation to find this one, not be necessary right now. You find g, okay, to find g, okay, hold on, let me restart. What I mean by you have to calculate the moments, okay, is you need to look at which one has 2 unknowns. Alright, I'm back. 2 unknowns. Alright, G has 2 unknowns. Number 1 and number 2. Alright, you don't know what they are. Alright, this is F, G, E. This is F, G, C. You have 2 unknowns here. But also, you have 2 unknowns at C as well, because you got this one and you got this one. So these should be instant red flags to use moments at these points, because if you took a moment at A, you're gonna have 3 different unknowns. Like, how's that gonna even work? You know what I'm saying? Like, oh well, we wouldn't have 2. You'd have 2, like, you know what I mean? You have 2 unknowns at G. So unknowns means you don't know the forces there. So what's very good about moments is you can completely ignore these 2 forces when you calculate it. So it's a mg equals to, we got B, okay, it's going that way. So that would be F, B, C times, so you can, that's, let me see. Pretty sure this is going anti-clockwise in that case. This one. So it's going 3 meters. Okay. and then we don't know if it's add or minus. This one's got to be clockwise for sure. Okay, 4 minus 4 times 3. And how do you know it's 3? Because if you're calculating the horizontal moment, you need to look at how far it is from there and vertically. Since that's 3, and vice versa, if you're calculating the vertical, you need to see how far horizontally it is, which is 3 as well. Now you got it. Therefore, do your little calculations. FBC should equal to 4 kilonewtons. And since we've been assuming tension, which means all our arrows are pointing out, and you may be questioning why this one's pointing in, well, simply, I mean, it just makes sense, right? It's compression happening here. I mean, it's external force, right? You don't have to worry about it, right? These forces are external, right? They added on outside, so don't worry about it. Right? The inside is what matters. So the inside's going tension. Okay, so 4 kilonewtons. Now we need to revisit C and C because there's 2 unknowns. So therefore, again, you don't need to worry about this one and this one. They're dead. FGE is what you need to worry about. FGE. Now we're just going clockwise, so negative. If you know it's negative anti-clockwise or clockwise, so if you just look here, I have to find it. Alright, anti-clockwise is positive. Why is that? Or you could do the other way around, your choice, but that's just what I was taught. You can see FG is going anti-clockwise, it's going 3 times 3. And now with the other force is this one, which is 6 away, and it's going clockwise. So minus 6 times 4, and do your little to FG should equal to what should it equal to? 24 to 8 kilonewtons. And that's the questions. Those are the questions answers, FGE and FBC, as you can see. And the only bonus question is to calculate the force at GC if it's tension or compression. Well, I did that by accident before. You literally, all you have to do is use either the right or left, who cares, I really said right and pointed to this one, that's kind of weird, and just calculate the equilibrium equation in the y axis, and you should be able to find it because there's only one force going up here, right? This is all horizontal, so you can negate them, don't care about them, and you literally have one force here, and it's just add equals 0, blah blah blah. So that's what you should do. Pretty easy question, easy. Let's get out of here.